As Nate has completed the real forces, large N, we're going to do the virtual forces, or small n in the equation. I'm going to draw a new free body diagram of the truss A, C, B. However, to do the virtual forces, you do not include the real force that was at B, 5 kips. Instead, you add a virtual force at E of value of 1 kip. Again, for the reactions, we have a vertical reaction A, but it's now going to be a virtual reaction. We also have one at C. We denote virtual by having a little prime next to the reaction force. There is also a horizontal reaction at A, but we will find easily that that will equal 0. As Nate said earlier, these forces each were 0, so we can immediately count those out in our calculations. We will start by doing external forces, finding for A prime y and C prime y. We do that by first, just like before, solving for a moment around A, which now gives us 1 kip 8 feet away. And then we subtract a CY, and that is 16 feet away. The whole equation equals 0. From this, we can see that C prime y is equal to half a kip. Also, just by looking at it in symmetry, CY is going to equal AY, so we don't even have to do equations of equilibrium anymore. AY is also equal to half a kip. Now we have solved for all the external forces, and we'll move on to the internal forces. To solve for the internal forces, we're going to use the method of joints like we did before, and we'll start with A. Here's point A, and there is member AE and member B, AB. As we said earlier, AF is 0, and here is the reaction force A prime Y. We can just start using the equations of equilibrium, do some of the forces in the y direction, which equals the y component of AE, and by the sine rule, it would be 6 over 10. Because this dimension is 6, and this dimension is 10. Here's 8. And then we add the vertical AY equals 0. So this gives us the force at AE to equal negative 0.833 kips. As we can see from the 0.833, it shows us that the virtual force AE equals 1/5 of the real force at AE. We can use this idea to solve for all the other forces. So that gives us also the virtual force at AB to be 1/5 of the real force at AB, and that equals 0.666 kips, 667 kips. Also from that, we can keep going and say that the virtual force of BC equals 0.667, which is also using symmetry because BC is symmetric to AB. And same goes for virtual force at CE, which will equal 0.833 So the only force we need left is BE. We already found all the other forces and these are 0. So quickly by using method of joint to B, there's force to A, force to C, and only one vertical force to E. Just by quickly looking, the sum of the horizontal forces is only force BE, which will equal 0. So now that we have our internal reaction forces, we can just plug them into our table. So force AB is 0.667. Force BC is also 0.667. AE is 0.833 negative. These are all 0 forces. BE is now 0 as we calculated using the method of joints. CD is a 0 force. Here is also negative 0.833. And the rest are 0. And now we'll just simply fill in the column for the length of each member. AB was 8, BC was also 8, AE is 10, AF is 6, BE is 6, CD is also 6, CE is 10, DE is 8, and EF is also 8. All we have to do is now sum across and fill in the last column. Sorry, multiply across. Multiply small n times big N times L. And that gives us 17.74 for AB. BC is also 17.74. AE is 34.71. And since these are 0, they just turn out to be 0 in this column. CE is also 34.71. And the rest are 0. Summing down for the total equation, adding these together will get 104.9 kibs squared feet. So back to our original equation, which was 1 kib, like Nate said, times delta. Here we are looking for the deflection at E. Our equation is sigma small m large N L over AE. Since we already found sigma, we can find that delta E is equal to 104.9 over A, which is 4.5 inches squared, times E, just 290,000. We also want to change the 104.9 into feet, so we'll have to multiply by 12. And that gives us a total final answer of 0.0096 inches of deflection.